Hplc instrument, which is short for high performance liquid chromatography, consists of a solvent, which is a mobile phase, which is pumped by a pump around the system through to the column, which is quite a short column compared to GC. This column can be somewhere between 10 and 30 centimeters in length. The components then will move then to a detector, and finally to chromatogram will be viewed on the computer. Now, the sample itself cannot be directly injected like GC because it's a high pressured system. The particle size are only about 5 micron in the Hplc column, so it's quite difficult to get a liquid through there. So the pump then is required to pump the liquid through the very short little column. Now, the sample injector system is different also to GC. It's not heated, it's not vaporized. The sample is injected into a reodyne valve, and then this in turn then, once loaded, is injected into the column. The components separate out on the column. Again, it's operated in two modes, normal phase and reverse phase, the most common being reverse phase. In this case, we have a mobile phase that is polar, and a stationary phase, which normally would be something like a C18 column. So two particles of silicate gel are bonded a liquid stationary phase of carbon chain length 18, making it a non-polar column. So competition between the mobile phase, which is polar, and the stationary phase, which is non-polar, for the components of the mixture give rise to differential migration. That is, that they migrate at different rates through the column and then hence hit the detector one at a time. Now, the detector can be a very simple detector like UV, and most are operated around about 254 nanometers, as anything with the chromophore, like a benzene ring, will absorb in this region. The computer then records the chromatogram and also will record the area under the peaks, because the area under the peaks are proportional to concentration. With the Hplc system, the most polar component will come off first, and a succession of components after that then in terms of decreasing polarity.